Okay, now let's move into doing the analyses for working with the chi-square contingency table now that we've got our hypotheses set up. Now the next step, let's first look at doing the critical value approach. And here our first step is locating what is going to be our chi-squared critical value. Now again, the critical value is the criteria that we set for our chi-square value. So we say our chi-square value has to be greater than our chi-squared critical value in order for us to reject the null. So in order to determine what our critical value chi-square is going to be, we're going to need two pieces of information. What are those? Well, we're going to need to know our alpha and our degrees of freedom. So what is the alpha here for this problem? Well, alpha is going to be 0.01. And our degrees of freedom, we're going to have to calculate differently. So our degrees of freedom is going to be R minus 1 times C minus 1, where R represents the number of data rows in the table, and C represents the number of data columns in the table. So if we were looking at this equation here, what is my R going to be? And what is my C? So here we're going to find my R is 2 and my C is 2. So plugging those into the equation, we get a degrees of freedom of 1. So now that we have our alpha and our degrees of freedom, take a few moments and locate in your chi-square distribution table what is your required critical value degrees of freedom. You should have gotten 6.635. So now that we have our chi-squared critical value, our next approach is going to be doing what? We've got to calculate our test statistics. We've got to find what our chi-squared obtained is. Now here we have the formula here on the right that we can go through and do by hand. And if we are working from our cells, we can go through and take our observed value for each cell and subtract the expected value from each cell, square it, and divide again by the expected. We would then get that value for each of the 4 cells, and then we would sum them together. We can also do this working with Stats Crunch. Now, if we're working with Stats Crunch, we have to pay attention to how we're entering the data. We have to set this up very differently than we have previously. So this is a key step in making sure that you're solving chi-square contingency table problems correctly. So you're going to have to set this up so it basically looks just like the table that we have here below. So you're going to have, for your first column, you're going to have your candidates for your row grouping. So here we have white candidate and black candidate. And then we have over here to the right, we have our column for passed and our column for failed. And we've entered in the values for those. So we open up your Stats Crunch and pause this video while you set up your data set just like that. And then once you have it set, turn the video back on and we'll move through the steps together and look at selecting the variables for your dialog box. Okay, so once you've got your data set in, you're going to go through Stat, Table, and Contingency, and you're selecting the options with Summary since that's what we're working with. Now notice this is a different location than when you were doing your other chi-square, so be very careful about this selection. All right, here when you're looking at this, you can see we've got our data columns there of passed, failed, right? So those are our outcomes. And then the row labels, mine are under just the variable 1, right? So there we have that there. And notice down here, the particular test it's automatically set for is the chi-square test for independence. So remember, this is what we're testing for, because remember the wording in our null and alternative hypothesis, where this is a test for independence. We're testing against the null assumption that the columns and the rows are independent of each other. So once you have that set, you should get an output that looks something like this. And again, you should be able to see a representation of your table. And then you can also see it's gone through and done the totals for you that we would be looking at for both your columns and your rows and the final set. Here we can see that we have our chi-squared obtained is our chi-square test value, right? So if you look across this table, you see it tells you you're doing the statistic we're doing as a chi-square. Our degrees of freedom is 1, as we've seen before. And our chi-squared obtained value here is 4.4232082. So remember, when we're rounding up, we're going to use our 3 decimal places to match the chi-square table. So that gives us a chi-square obtained of 4.423. So now what's going to be my next step here? Well, my next step, of course, is going to be to graph it out. So here we can see graphed over here on the left-hand side, we have the distribution where I've marked in my chi-squared critical value of 6.635. Now let's think about where we're going to mark this for the reject the null hypothesis and the fail to reject the null hypothesis regions. So the rejecting the null region, is that going to go to the right or to the left of my chi-squared critical value? Well, that is going to go to the right, and my failure to reject the null is going to be on the left. The last thing I need to do is mark in my chi-squared obtained. So where's my chi-squared obtained going to map onto this distribution table figure? Well, it's going to go here, so it's going to wind up to the left of my chi-squared critical value. So looking at all of that, we have it graphed out. Now we need to assess a rejection region. So looking at this, are we going to reject the null or do we fail to reject the null? We're going to fail to reject the null. So our chi-squared obtained is falling within the fail to reject the null region. So coming up and looking at this, we now need to connect this back with our restating our decision in non-technical terms. We need to pull up our null and all alternative to make sure that we are connecting with those. And our conclusion statement is going to read like this. There is not sufficient evidence to reject the claim that there's independence between the row and the column variables. So notice when we're writing this out, you're either going to start off with there is sufficient evidence to reject the claim or there is not sufficient evidence to reject the claim. And then you're going to restate the claim, the null claim, that there's independence between the row and column variables, since that is what we were actually testing. It appears that whether or not one passes the test is not dependent on race, since that is what we've established, since they are independent. The evidence does not support the claim that the test is discriminatory. So that is the final statement, and connecting it back with the overall driving question of, is this test discriminatory or not? And whenever you're writing your conclusion, you're going to have some basic components for this. So you're going to have a statement of whether there's sufficient evidence or not sufficient evidence to reject. And then you're going to state the claim from the null hypotheses, okay, since that's what we're actually testing. Then you're going to translate that back in your next sentence as to what did that mean for the question that they were asking about. So it appears here that whether or not one passes the test is not dependent on race. So I've now taken that null hypothesis and translated into the variables that we're interested with here, which is race and passing the test, and then summing that up as to how it relates back to the overall arching question of whether or not the test is discriminatory. Okay, now let's also go through real quickly and look at this with the p-value approach. So what are the first couple steps I need to have if I'm going to do a p-value approach with this problem? Well, I'm going to identify my specified alpha, and then we're going to use the p-value from StatsCrunch. So what is my specified alpha here? My alpha is going to be 0.01. And then looking at the StatsCrunch for the p-value, we've already done that calculation. We can see it there. So it's going to be 0.0355, again with our rounding rule, 0.036. So taking that value, what's going to be my next step now? Well, I've got to compare them. So is the p-value less than or equal to my alpha? If it is, I'm going to reject my null. If it's not, I'm going to fail to reject my null. So we plug in our values for this problem. We're going to get 0.036 is less than or equal to 0.01. Is this a true statement? No, it is not a true statement. Therefore, we fail to reject the null. And moving up to applying this then back to restating our decision in non-technical terms, again, we come to the same conclusion.